There is a red point of light that rises in the east on most nights of the year. You have seen it. Everyone alive has seen it. It does not twinkle like a star. It moves differently, slower, with a quiet intention that the ancients always noticed and we have mostly forgotten. For thousands of years, the people who looked up at that red dot and tried to understand what it was reached the same conclusion, independently, across cultures that had no contact with each other. And Bruce Yakowski, the principal investigator of NASA's MAVEN mission, has spent 10 years watching an atmosphere evaporate in real time, confirming, with instruments those ancient observers never had, that they were closer to the truth than anyone expected them to be. Let's start with the pattern itself, because the pattern is the strange thing. The Sumerians called that red dot Nergal, not a minor deity, a god of war, of plague, of the underworld, the god of inflicted death. As one scholar put it, his main cult city was Cutha, and clay tablets 4,000 years old still describe him as the bringer of unstoppable calamity. The Babylonians inherited him and kept the association. When Greek astronomers looked at the same red point more than 1,000 years later, they called it Ares, the only Olympian the Greeks openly despised, the god of bloodshed and chaos, attended into battle by his son's fear and terror. The Romans renamed him Mars and added agriculture as a later graft, but his core identity never changed. In Egypt, the planet was called Herdesha, the Red One, and associated with a version of Horus that ancient priests linked to disorder and drought. In India, the Skanda Purana describes Mangawa, the Mars deity, as having been born from the sweat of Shiva. In Hindu astrology, a child born under his influence has Mangal dosha, an astrological condition so persistent that arranged marriages in modern India still account for it. The Chinese named the planet Huo Crossing, the fire star, and tracked its motion for over 2,000 years as an omen of rebellion, fire, and warfare. The Norse honored Tyr, the one-handed war god, and when the Romans translated their calendar into Germanic, Dies Martis became Tyr's Day, Tuesday, Tyr's Day, Mars's Day. 8 civilizations, separated by oceans, by languages, by millennia. All of them looked at the same red dot and arrived at the same verdict. And here is where the explanation everyone reaches for starts to wobble. The common story says the red color alone explains it. Red like blood, red like fire. The human mind sees red and projects war, perhaps, but the story does not explain why the specific motifs, plague, underworld, inflicted death, the companion spirits of fear and terror, repeat in the same order across cultures that spoke no common word. It does not explain why the Sumerians, without any telescope, tracked Mars's retrograde motion and embedded it in their omen texts with astonishing precision. It does not explain why the first astronomers, who had no way to measure distance, brightness, or chemistry, still agreed that this particular wanderer was different from all the others. Something about that red dot unsettled the first humans to look up with attention. And when modern instruments began to study what they were actually looking at, the only started to have a name. Because Mars is not a planet that gently cooled into deadness. Mars is not a planet that was simply never habitable. Mars is a planet that was once something very similar to Earth. And then something happened. Something that left behind canyons 4 times longer than the Grand Canyon, ocean coastlines still visible from orbit, and a crust that is still losing air into space at a rate you can measure in grams per second. The ancients saw a dead god in the sky. The data is starting to suggest they may have been looking at a murder scene. For most of human history, the only thing visible about Mars was its color and its motion. That changed in 1877, when the Italian astronomer Giovanni Schiaparoli pointed a telescope at the planet and thought he saw canals, he did not. What he glimpsed were the first hints of something larger, a surface with geological features that should not exist on a dead world. The first serious confirmation came in the 1970s. Mariner 9, followed by the twin Viking orbiters, mapped a canyon system called Valles Marineris. The name itself is understated. Valles Marineris is 4,000 kilometers long. It is 600 kilometers wide at its deepest. It drops 11 kilometers below the surrounding plateau, deep enough to hold the entire Grand Canyon stacked 4 times over. And it did not form from water erosion alone. It formed when the crust of Mars tore open, as the planet cooled, and a nearby volcanic bulge called Tharsis inflated. Tharsis itself covers 25% of the planet's surface. Olympus Mons, its largest volcano, rises 21 kilometers above the reference level, about 2.5 times the height of Mount Everest. Nothing on Earth compares, because Earth's plate tectonics smear the heat across its crust. On Mars, all the heat went to one place, and that place built a volcano roughly the size of the state of Arizona. So far, none of this tells you Mars was alive. Volcanoes are not life. Canyons are not life. The question was always the same question. Was there water then? In 2012, the Curiosity rover landed in Gale Crater and found rounded pebbles, the kind that only form when water rolls them along a stream for long periods. A decade later, Perseverance landed in Jezero Crater, a 45-kilometer basin that ancient satellite data had flagged as a possible river delta. Perseverance confirmed the delta. It found sedimentary rocks, the same kind that on Earth preserve microbial fossils, as of 2025. The rover has sealed 33 sample tubes containing the most scientifically valuable Martian material humans have ever collected. And then, in January of 2026, a research team led by the University of Bern in Switzerland announced something that shifted the conversation again. They had identified ancient deltas along the length of Valles Marineris, not stream deltas, but deltas that appeared to have fed an open ocean. An ocean at least as large as Earth's Arctic Ocean, an ocean that covered about half of Mars. Let that land for a second. Mars, the cold, dead, salmon-colored desert we have sent robots to since the 1960s, once had an ocean covering half its surface. It had rivers long enough to stretch from New York to Kabul. It had lakes deep enough to fossilize mud. It had a sky thick enough to support liquid water at the surface, which means it had pressure. And pressure means atmosphere. And atmosphere means something was holding the atmosphere in place. For more than 1 billion years, Mars was a blue planet with a red hue at its edges, warmer than it is now by about 60 degrees Celsius on average, wetter than any patch of Earth's driest desert, running its own hydrological cycle under a sky that would have looked, to any visitor, almost familiar. That world is gone. Every particle of that ocean is either locked in the polar caps as frozen water, buried beneath the crust as ice, or scattered across the solar system as atoms the solar wind carried away. What you see today is the corpse. The atmosphere the ancients named the god of death has been proven, by measurement, to be what was actually killed. Now the question is how. To understand what killed Mars, you need to understand what kept it alive in the first place. Every planet with an atmosphere has 2 problems at all times. The first is gravity. The planet has to be heavy enough to hold the air down. The second is shielding. Something has to protect the air from being blown away by the solar wind. Mars has 38% of Earth's surface gravity. That is less than ideal, but it is enough. A planet the size of Mars can hold onto a significant atmosphere indefinitely, as long as the second condition is met. That condition is a magnetic field, a global dynamo, powered by convection in a liquid metal core, wrapping the planet in an invisible shield that deflects charged particles streaming off the Sun at 400 kilometers per second. Mars had one. We know this because the crust of the southern hemisphere is striped with remanent magnetism, permanent magnetic signatures imprinted into ancient rocks at the moment they cooled, frozen into place by the dying field they once recorded. Measurements from orbiting spacecraft show a crustal magnetism so strong in places that, if it were transplanted to Earth, it would be the most powerful magnetic region on our entire planet. That is the fossil of a field that no longer exists. Then, somewhere between 4.5 and 3.7 billion years ago, the dynamo stopped. Recent research, using a quantum magnetic field microscope on returned meteorite samples, places the shutoff at around 3.9 billion years ago or later. Debate continues about exactly when, and whether the field weakened gradually or switched on and off repeatedly as it faded. But the consensus is clear. At some point early in Martian history, the core stopped generating a protective field. And the day that happened, the clock started ticking. This is where MAVEN comes in. The Mars Atmosphere and Volatile Evolution mission, a spacecraft the size of a small bus, has been orbiting Mars since 2014 with a single scientific purpose: measure, with extreme precision, how fast Mars is losing its atmosphere right now, and project backwards what that loss looked like across billions of years. The headline finding, reported by Bruce Yukowski and his team at the University of Colorado Boulder, is that Mars loses roughly 100 grams of atmosphere to space every second. That number rises during solar storms. During coronal mass ejections, the violent bursts of plasma the Sun sends outward when its magnetic field snaps, the loss rate can spike by an order of magnitude. 100 grams per second does not sound like much. A small apple hitting the upper atmosphere and disappearing. But stretched across the age of the solar system, that rate is the mass of an ocean. It is the pressure of an entire breathable sky. It is every warm morning, every river, every weather system that Mars ever had, lost, atom by atom, to the solar wind. The loss happens in 3 places. About 75% escapes down the tail, where the solar wind flows past the planet and drags ions with it. A further 25% escapes above the poles, in what MAVEN scientists call a polar plume. A smaller fraction leaks from an extended cloud surrounding the entire planet. Each escape path is a different mechanism. Each one is still active. As you hear this sentence, Mars is still losing air. This is what it looks like when a planet is murdered, not in a single event. Slowly, patiently, over billions of years, the solar wind grinding away at a world whose shield had failed. And this is the part that makes the MAVEN data unsettling in a specific way. The same process is visible, at a much smaller scale, on a planet much closer to home. Earth's magnetic field is currently weakening. The weakening is not catastrophic. The consensus is that we are nowhere near a shutdown. But the viewer who understands the Martian timeline understands something specific. Planetary magnetic fields do not weaken forever, without consequences. And here is where the story has to leave Mars itself for a minute. Because 2 of the strangest objects in the Martian system are not on Mars, they are orbiting it. And they do not fit, Phobos and Deimos. Their names are Greek, translated. They mean fear and terror. The ancient Greeks named them as the sons of Ares, the companions who rode into battle with the war god, the spirits who spread panic through opposing armies. When the American astronomer Asaph Hall discovered the actual moons in 1877, he honored the myth and gave the moons those names. He could not have known how appropriate it would turn out to be. Phobos is small, about 22 kilometers in mean diameter, deeply cratered, shaped like a lumpy potato. It orbits Mars 3 times every Martian day at an altitude of only 6,000 kilometers, which is less than the distance from Paris to Tokyo. Nothing in the solar system orbits its parent planet that close, and its density is strange. Measurements from the Mars Express spacecraft place Phobos' bulk density at 1.876 grams per cubic centimeter. That is much less than a rock, much less than the asteroid it resembles. The leading hypothesis is that Phobos has significant empty space inside, perhaps 30% porosity, perhaps a rubble pile held loosely together by its own feeble gravity, not hollow in the science fiction sense, but shot through with voids in a way that suggests an origin story nobody has fully written. Its surface is scarred with parallel grooves that nobody fully explains. For decades, the grooves were attributed to stress fractures from an ancient impact. Recent analysis, published in 2018, showed that the grooves align not with the old impact crater Stickney, but with the leading direction of Phobos' orbit, as if the Moon were dragging something across its own surface. One current hypothesis proposes that the grooves are scars from boulders ejected from Stickney that bounced across Phobos in chains before returning to space. Another proposes that they are tidal cracks, the first visible signs of a body being pulled apart by the planet below it, because Phobos is not in a stable orbit. It is spiraling inward, slowly, toward Mars. Tidal forces from the planet below are stealing its orbital energy at a rate that can be measured to millimeters per year. At the current rate, somewhere between 20 and 70 million years from now, Phobos will cross the Roche limit, the gravitational boundary inside which a body cannot hold itself together against tidal stress. When it crosses, it will break apart. It will become a ring. Simulations from Purdue University show that the fragments will spread into a band of debris around Mars that will rival the early structure of Saturn's rings for at least 1 million years. Possibly 100 million. For a geological heartbeat, Mars will regain the appearance of a ringed planet, a pale echo of Saturn, carved from the corpse of a moon whose name means fear. This may not be the first ring Mars has had. Some planetologists now argue that Phobos and Deimos themselves are the remnants of an earlier ring system, that Mars once had a series of moons that were formed from debris, crashed back into the planet, reformed from the wreckage, and crashed again. In a cycle driven by the tidal forces of the world they orbited. If this model is correct, Phobos is simply the last surviving shard of a much older catastrophe, which returns us to the question the ancient Greeks somehow encoded into their myth without knowing any of this. Ares was attended by fear and terror. The planet named for him is orbited by fear and terror. And one of those companions is doomed to fall. None of this proves anything. It is a coincidence between language and celestial mechanics. But it is a coincidence of the same type as the pattern the Sumerians started, the one the Babylonians continued, the one 8 civilizations shared. The kind of pattern that, once you see it, you cannot quite unsee, return to the planet itself. Because even with the dynamo shutdown and the solar wind, the strangeness of Mars is not exhausted. Look at the planet from orbit. The northern hemisphere is smooth, lowlands. Few craters, almost featureless from a distance. The southern hemisphere, as the opposite, heavily cratered, mountainous, geologically ancient, and on average 5 to 8 kilometers higher in elevation than the north. This dichotomy is one of the most extreme topographic divides on any known solid body in the solar system. Nothing comparable exists on Earth, on Mercury, on Venus, or on our own moon for decades. Planetary scientists debated whether the dichotomy was internal, the result of a lopsided convection cell in the Martian mantle, or external, the signature of a catastrophic impact. By the late 2000s, a series of papers made the external case with force. Using topographic data from Mars Global Surveyor and gravity data from Mars Reconnaissance Orbiter, researchers mapped the boundary of the dichotomy and found an elliptical shape, an enormous ellipse, roughly 8,500 kilometers across by 10,600 kilometers long, covering 40% of the planet's surface. The shape is the shape of an impact basin. And if that is what it is the largest impact basin ever found anywhere in the solar system. The Borealis Basin, the impactor required to carve it, is estimated to have been somewhere around 2,000 kilometers across, or larger than Pluto, a small planet, striking another small planet. The collision, early in Martian history, would have been one of the most violent events in the inner solar system since its formation. Its energy would have vaporized a significant fraction of the existing crust, reshaped the entire northern hemisphere, and potentially ejected enough debris into orbit to eventually coalesce into the moons that later became Phobos and Deimos. The Borealis impact hypothesis is not without critics. A 2024 study argued that a northern impact of that scale have produced specific antipodal effects on the southern hemisphere, effects that are not clearly present on the surface today. That paper proposed an alternative in which the dichotomy was caused by a southern impact producing a localized magma ocean that crystallized into the thicker southern crust we see. The debate is active, and new modeling continues to emerge. What both sides agree on, that something enormous happened to early Mars, something large enough to rewrite a third or more of its surface, and the timing is suspicious. The same era that saw the Borealis impact, or whatever catastrophic event it turns out to have been, is roughly the same era in which the Martian dynamo began to falter. Coincidence, on a scale like that, stops being a comfortable word. Layer the evidence. An impactor possibly the size of Pluto. A magnetic field that died around the same time. An atmosphere that has been bleeding into space for billions of years afterwards. Moons whose densities and orbits suggest they are debris from something ancient and broken. A landscape covered in river valleys, delta deposits, and the ghost of an ocean that once stretched across half the planet. The ancient civilizations who painted Mars as death did not know any of this. They did not know the planet had been struck. They did not know it had lost its shield. They did not know its atmosphere was still draining. They looked up and saw a red wanderer that made them uneasy in a way the other wanderers did not. And now, when the instruments are turned on the same red point of light, they are finding, one anomaly at a time, that the ancients were describing something real. A world that was once alive, a world that suffered something, a world whose memory, somehow, survived in human language for 5,000 years. Here is where the story turns. Because the story was never really about Mars, Earth's magnetic field has been weakening for the past century and a half. Since 1840, the year systematic measurements began, the global strength of our planet's field has declined at roughly 5% per century. In the past 50 years, a particular region, the South Atlantic anomaly, has become the visible edge of that decline. The anomaly now covers an area nearly half the size of continental Europe. It continues to expand. Spacecraft flying through it experience elevated radiation exposure and occasional instrument glitches. As of January 2026, new global models showed the weakening accelerating in certain regions faster than earlier estimates predicted, with the minimum field strength in the most affected area dropping from around 24,000 nanoteslas to 22,000 in the past half century. None of this means Earth is becoming Mars. The geomagnetic consensus is clear. A full reversal, if one comes, takes thousands of years. A full shutdown, if one ever occurred, would take scales of time that make human civilization vanish as a footnote. But the mechanism is the same mechanism, the liquid iron core convecting. The dynamo, running, the invisible shield, holding the atmosphere in place. On Mars, the dynamo stopped. On Earth, it is still running. That is the only difference that matters. And the exact reason why one kept going while the other failed is a question that planetary science has not fully answered. The mission that could have answered it, at least partially, was Mars sample return. Perseverance has been collecting samples since 2021. 33 tubes are sealed and waiting. They contain delta sediments, mineral records of ancient water, organic molecules already detected by the rover's onboard instruments, carbonate minerals capable of preserving microbial signatures across billions of years, and igneous rocks whose magnetic orientation could freeze date the dynamo shutdown with a precision no orbital mission can ever achieve. That material is still on Mars in January of 2026. The United States Congress effectively cancelled the Mars sample return program, eliminating almost all funding for future retrieval missions. The samples are still sitting on the surface of Mars, in sealed tubes, waiting for a spacecraft that is no longer being built. MAVEN is still running. Its extended mission continues to track the atmosphere's ongoing escape. A proposed Chinese mission, Chang'e-3, is planned to attempt its own sample return later in the decade, which may end up being the first return of Martian rock to any laboratory on Earth. The story of Mars is not over. It is simply, for now, paused, and the red point of light continues to rise in the east. The same red point the Sumerians named Nergal, the Greeks named Ares, the Hindus named Mongala, the Chinese named the Fire Star, the same red point you can step outside tonight and see for yourself. It is brighter some months than others. It moves against the stars with the slow intention the ancients noticed. And if you know what you are looking at, you are looking at the answer to a question most of humanity has never thought to ask, which is why, on a small blue planet orbiting a yellow star, life is still possible at all. The difference between Earth and the dead God hanging in our sky is one invisible thing, and that invisible thing has been keeping us alive every second of every life that has ever been lived. Thanks for watching, and I'll see you in the next one.